In this lesson, we will quantify the benefit of a 16-entry write combining buffer on a write through level 1 cache for 64-byte streaming stores. Our goal is to compute how much we cut level 2 transactions when the measured write coalescing is 64%. We will solve this both mathematically and graphically and carefully explain each concept. First, the big picture. A write through level 1 cache forwards every store to level 2 without any buffering. That means one level 2 transaction for every store. A write combining buffer sits next to the level 1 and catches writes to the same cache line. It merges or coalesces them into a single burst right of the full line to level 2. With 16 entries in the buffer, you can track up to 16 different lines in flight before an early flush happens. Let us visualize a single 64-byte cache line being produced by several smaller stores, for example 8-byte chunks. Without combining, each 8-byte store immediately goes to level 2. That means 8 separate level 2 transactions to write one 64-byte line. Now, with a write combining buffer, those 8-byte stores to the same line are caught in one entry. They fill the line in the buffer. And only when the line is complete or evicted do we send one full line right to level 2. Ideally, that turns 8 transactions into just one per 64-byte line. Let us quantify the savings using the measured coalescing of 64%. Define n stores as the total number of stores. With a write through level 1 and no combining, the baseline number of level 2 transactions equals n. With write combining, a fraction C of stores are merged into existing transactions, so they do not create new level 2 transactions. The remaining fraction, 1 minus C, still generate separate transactions. Therefore, the new number of level 2 transactions equals 1 minus C times n. We can also express the improvement as a factor. Only 36% of the baseline transactions remain, so the level 2 traffic for these stores is reduced by roughly a factor of 1 divided by 0.36, which is about 2.78 times less traffic. Let us anchor this with a concrete example. Suppose we stream 160 cache lines, each 64 bytes, and we write them using 8-byte stores. That is 8 stores per line. So the total number of stores is 8 times 160, which equals 1,280. Baseline, without combining, that would be 1,280 level 2 transactions. With 64% coalescing, only 36% remain, giving 0.36 times 1,280, which equals 460.8, or about 461 transactions. On average, that is about 2.88 transactions per line, compared to the ideal of 1 per line. A quick picture helps. Imagine the baseline traffic as 100 units tall. After 64% coalescing, the remaining traffic is 36 units tall. For comparison, the ideal case of perfect coalescing for 8 stores per line would be 1/8 of baseline, or 12.5 units. Why not 100% coalescing all the time? The 16-entry buffer limits how many different lines can be merged at once. If your streaming pattern touches more than 16 lines in close succession, partial lines get evicted and flushed early. That forces extra level 2 transactions and reduces the coalescing percentage. With a tight sequential stream touching at most 16 lines in flight, you approach the ideal of 1 transaction per line. With more interleaving, you move toward the measured 64%. Summary: on a write through level 1, a 16-entry write combining buffer merges many small stores to the same 64-byte line into a single level 2 line write. With 64% coalescing, the new level 2 transaction count is 36% of the baseline. That is a 64% cut, or about 2.78 times less traffic for those stores. Graphically, we saw many red arrows shrink to a single green arrow per line, and our bar chart captured the reduction at a glance.